Betelgeuse, the red star that is located in the shoulder of the Orion constellation, has been behaving in a peculiar manner recently, which has increased expectation for an event that will only happen once in a lifetime. The James Webb telescope just detected sudden 250% increase in Betelgeuse's brightness. Yet again, the 10th brightest star in the night sky, Betelgeuse, is causing scientists to scratch their heads. This time around, it is 50% brighter than before. Some people are wondering whether or not we are about to see a supernova in the Betelgeuse star system, given its recent rise in brightness. We would not be harmed, but because to the fact that the Sun is around 724 light-years away from Earth, we would be able to witness the incredible flash that would be created by such an occurrence. Betelgeuse has been increasing darker and brighter in recent years. In 2019, the star's brightness was reduced to around 1/3 of what it had been previously. The Himawari 8 weather satellite made several observations that were not intended to be acquired. These observations show that the great dimming was caused by a combination of the star's cooling and condensation induced by a neighboring dust cloud. Just a few short years later, the James Webb telescope just detected sudden 250% increase in Betelgeuse's brightness. The red supergiant occupies the position of the Orion constellation's second brightest star. A pulsing semi-regular variable star also describes this celestial object perfectly. This essentially denotes that the brightness of it shifts on a somewhat periodic basis as time goes on. Betelgeuse's brilliance goes through cycles that last for around 400 days. It also has a 125-day cycle, a 230-day cycle, and a 2,200-day cycle. The life of a star is spent turning hydrogen into helium as its fuel, a process that keeps the star from crumbling under its own weight and ending its existence. However, as a star runs out of hydrogen, the helium begins to burn into carbon, which causes the star to expand. This process continues until the star has no more hydrogen. When all of the star's fuel is used, it is no longer able to support its own weight and eventually transforms into a neutron star after collapsing under its own gravity. Betelgeuse may have reached the ultimate stage of its life cycle, which is the carbon-burning stage, according to the findings of a report that was published not long ago by Tohoku University in Japan. The lifespan of the star is rapidly coming to an end. Betelgeuse is thought to have departed from the main sequence of stars and evolved into a red supergiant at 8 to 8.5 million years ago. This indicates that the star converted all of its hydrogen fuel into helium, which resulted in the star expanding and becoming cooler as a result of the transformation. As it continues to fuse helium into heavier elements such as carbon, the star will, in time, create even heavier elements, leading to its final demise in a supernova. A number of scientists have the opinion that the star is currently in the last phases of this process, but it is unknown how much time is left at this point. Yet defining where in the process of its evolution Betelgeuse currently resides is not a cut-and-dried matter, and some astronomers are of the opinion that it has not yet completed burning all of its helium. An investigation of the recent rise in the star's luminosity, which was presented to other researchers for assessment, found that there are a variety of potential explanations for the star's enhanced visibility. One of them is the possibility that the star Betelgeuse may go supernova within the next 10 years. However, this is not the only scenario that might occur. In spite of the lack of precision surrounding the precise date, there is one thing that can be said with absolute certainty. Betelgeuse will go supernova. Eventually. When it does, the night sky will be illuminated by its brilliant glow. The supernova that we now refer to as SN 1006 took place in the year 1006 CE and was so brilliant that it could be seen for several months after it happened. People who lived more than 1,000 years ago may have been able to read by the light cast by the supernova, according to the theories of certain scientists and historians. In Switzerland, Benedictine monks wrote of a star that was glittering in aspect and dazzling the eyes, causing alarm. Ali ibn Ridwan, an Egyptian physician and astronomer, stated that the sky was shining and calculated that the supernova was 3 times as luminous as Venus at the time. Astronomers of today believe that the supernova occurred around 7,200 light-years away from Earth. Johannes Kepler, a German astronomer, was the first person to document the Milky Way galaxy's most recent supernova, which occurred in 1604. It lasted for a few of months total. At the peak of its brilliance, the star, which is now referred to as SN 1604 or Kepler's supernova, and which is documented in Kepler's book De Stella Nova, grew brighter than both Jupiter and Mars. Astronomers predict that the supernova that will result from the explosion of Betelgeuse will have a brightness comparable to that of the Sun. Beginning in December 2019, scientists saw a peculiar and significant attenuation in the light coming from the brilliant red star Betelgeuse, which is located in the Orion constellation. They were perplexed by the phenomena and speculated that it may be an indication that the star was going to go supernova in the near future. A few months later, they had limited the most plausible explanations down to two: either a temporary cold area on the star's southern surface, similar to a sunspot, or a clump of dust that was causing the star to seem dimmer to viewers on Earth. This was done after they had observed the star for several months. According to a new research that was recently published in the journal Nature, our question has been resolved. Even if dust is the principal offender, it is connected to the momentary appearance of a chilly area. In the latter half of 2019, Betelgeuse faded to the point that the difference could be seen with the naked eye. The dimming continued, with the brightness dropping by 35% in the middle of February. It did not recover its previous level until April 2020. Telescopes that were aimed in the direction of the giant were able to detect that rather than a neat and uniform decline in brightness, Betelgeuse's dimming was unevenly distributed. This caused the star to seem to have an irregular and compressed shape when seen from Earth. This led to a lot of people being curious about what exactly was going on with the giant, and many specialists hypothesized that due to Betelgeuse's enormous size and old age, the peculiar behavior may have been a precursor to a supernova that was about to occur. Around the middle of the year 2020, astronomers had a change of heart. It just so happened that a group of observers from across the world had the Hubble Space Telescope aimed in the direction of Betelgeuse before, during, and after the dimming event. These UV data, when combined with some opportune ground observations, suggested that a large burp that resulted in the formation of a cloud of dust surrounding the star may have been the reason of the star becoming less bright. The observations from the previous years demonstrated that an outer layer of the star known as the photosphere had started moving outward in an irregular manner just prior to Betelgeuse beginning to fade. The photosphere was traveling at a speed of around 7 kilometers per second at its peak, which reversed the outward push that was occurring as the star's brightness began to decrease more noticeably. Do not forget to subscribe and turn on post notification to be notified on the next post. It was hypothesized by Dupree and her co-workers that a convection cell had made its way from the core of the star to the surface when the star expanded during one of its typical cycles. This cell would have caused a region of the star's surface to speed up far faster than it would have otherwise. When taken together, these two occurrences pushed out sufficient material to a distance far enough from the star for it to cool down and create stardust. It's possible that the dimming was caused by the dust. Astronomers were able to directly see the production of stardust thanks to these photos, which, when paired with prior observations made in January and December of 2019, allowed them to do so. These observations matched those made by Dupree and her colleagues the previous year. The ESO team came at the conclusion that a bubble of gas was expelled from the star and then pushed further out by the outward pulsing of the star. When a convection-driven cold patch emerged on the surface, the local temperature decreased to the point where it was sufficient to condense the heavier components, such as silicon, into solid dust. This resulted in the formation of a dusty veil that dimmed the star's light in its southern hemisphere. The scientists have a theory that a comparable process, in which dust is expelled from cold stars, might result in the formation of planetary building pieces, massive force detected in the universe. Click next post to find out what it is.